Hi, welcome to today's project. Today I want to install a new outlet to charge my Bluetti AC300. As you can see, the Bluetti AC300 is right here with the B300 battery at the bottom. Over here we have an AC outlet in which we have the Bluetti plugged in. Now that outlet is connected to one of the breakers in the breaker box on the other side of the wall here. But it also, if I turn that breaker off, which will turn off that outlet, it will also turn off multiple other outlets in the house. So I want to install a new outlet just to the left, somewhere behind the AC300, that will be dedicated to the AC300. Now, if we pan up just a bit, from this angle, you can see the Reliance ProTran 2 manual transfer switch. It's flexible conduit, which goes into the wall there. And just behind that wall is the main breaker box for the house. So the plan is to drop a wire straight down behind the AC300, which is slightly below, and put a new outlet that'll be dedicated to the AC300. Now this is going to require some wiring, another outlet, and a new breaker inside of the breaker box. In order to do this job properly, we're going to need several different tools. The first tool we have is called a diagonal pliers. This is used mainly for cutting the wire. Another handy tool to have is alignment pliers. This is nice when you need to grasp, pull, and bend wire. It also has a cutting portion right here. Another useful tool is a wire stripper. Now, wire strippers come in a variety of shapes and sizes and forms. This one is an automatic stripper. If you look closely at the blades there, you can make out the different sizes. I close it down a little bit, so depending on the wire size, you put it in the appropriate hole. You continue to squeeze, and the jaws come together in the back holding the wire, and then pull the insulation off the wire. These are really nice to have, but there are other ones that are a little bit cheaper than this if you don't have one of these. Several different straight blade screwdrivers, a keyhole saw, which is useful for cutting the hole in the wall where we have to put the outlet box in, a number 2 Phillips head screwdriver, a Romex ripper. Now this has a very sharp point in there that pierces the outer jacket of Romex wire and allows you to easily remove it. Some electrical tape, a non-contact voltage detector to make sure that you've got the circuit off. These are really nice. They are relatively inexpensive. You simply press the button, it turns on, and it lights up green. When it comes near a voltage source, it beeps and turns red. Press the button again to turn it off. We'll show you how that works once we get started on the project. An outlet tester. These are great because you can just plug it in, and if you get 2 lights, as it shows here on the bottom, you've got the correct wiring. Any other combination of lights indicates there's a problem. This is great to check your work after you've finished doing the job. This is fish tape. It's used for fishing wires through walls. We're going to use this to feed the wire from the box down to the outlet. This is a non-conductive type. It's fiberglass. There are some that are made out of metal, but this is nice because you can use this even if the wires are energized. Now that we've looked at the tools that we need, let's look at the materials we need to do the job. First thing we're going to need is a drywall box. Now we're going to put this into an existing wall, so this is the type of box we're going to use. It's got these little ears, one on this side and one on the other side. We'll cut a hole out, push this into the wall, and then using these screws right here, these little ears will pop up and press against the wall, keeping this box from pulling out. This is the type of box you have to use when you've already got an existing wall. Next up, we need an outlet. Now this is just your standard duplex outlet. It's got a grounding screw here. This side connects, your white wire connects to the silver colored terminals, and your black wire connects to the brass colored terminals. This is a polarized outlet. You'll notice that this side here has a smaller opening than this side, so it's very important that you wire this correctly. Black wire to the brass, white wire to the silver, ground wire to the green. The outlet tester will be plugged into this after we finish the job, and of course if you've got it wired backwards, that outlet tester will tell you that. A Romex wire clamp. Now the Romex wire goes through this opening right here, and then these screws tighten down to clamp the wire in place. This lock nut on the bottom here comes off, and this part goes up into our breaker box. This goes on top from the inside of the breaker box and tightens down to hold the clamp in place. Cover plate to cover the outlet once we're done, and some Romex wire. Now this type of wire is called 12-2 with ground. If you take a close look at it, you see it has 1, 2, 3 conductors. The 12 refers to the size of the wire, our gauge. The 2 refers to the 2 conductors, the black and the white, black being your power and white being your neutral. And then with ground is referring to this bare copper wire, which is your ground wire. And finally, the last piece of equipment we're going to need for this project is a circuit breaker. This is a Siemens circuit breaker, which fits this particular panel. It's a 15 amp breaker. It has a lug here where the black wire will attach, and you just snap it into position in that blank spot that we removed. In order to get this project started, we first have to locate our main breaker box, which in this case is behind this panel. Opening up the main breaker box allows us to see if there's any room available for an extra breaker. As you can see, to the bottom left, there's plenty of room here. Let's zoom in so we can get a better look. So you can see right here, we've got a blank. We're going to take this blank right here, we're going to take that out, and that's where our new breaker is going to go. In order to get that blank out, we're going to remove the 4 screws you see. With the panel now removed, we could use our lineman's pliers to remove the blank. Now using our lineman's pliers, we're going to try and twist out this particular blank right here. All right, so the blank has now been removed and we're ready to go to the next step. With the panel removed, we now have access to the wiring. Now this box is currently live. We have not turned off the power yet. I'm going to use my non-contact tester to demonstrate that we do have live wires here. These 2 black wires, this one over here and this one over here, are the mains coming in from outside. As you can see, I don't even have to touch them to get an indication that there's voltage flowing through them. There is a main breaker right here, but that main breaker will only turn off the circuit breakers that are below it. So flipping this main breaker switch will disconnect these breakers down here on this side and the breakers over here. In order to turn off these large mains, which are coming from the outside of the house, we need to have a main breaker outside. In this case, I do. So in order to do any work on this box and do it safely, I'm going to turn off that main breaker, which will de-energize these lines, and then we'll come back and test them after we've thrown the main breaker. Now I'm outside of the house, and you see the meter on the right, and in the middle is this very large box. That is the main disconnect. Throwing that switch will turn off all the power to the entire house. There's the main disconnect switch. It's currently in the on position. And we're going to turn it off. So we're back at our main panel in the house with the main disconnect off. Now with the no contact voltage detector and the big main switch off outside, there's no electricity flowing. So now that the main switch is off, we've used our no contact voltage detector to make sure that the mains are completely off. We're going to take this knockout right here out, one of these, so that we can get started on the wiring. Now, I've decided to take this knockout right here. You really can't see it. It's hard to get the camera in there because the wires are in the way. But this knockout here, where my finger is pointing, is probably the easiest one for me to get to and get the wire in. But you really can't do the knockout from this side. The knockouts are designed to be pushed up into the box and then twisted out with alignment pliers. So I'm really not going to be able to film this. I'm going to go on the other side of the wall. I'm going to get underneath, and I'm going to push that up a little bit with a screwdriver. From there, I'll grab it with alignment pliers and twist it loose. All right, so now what I'm going to do is remove that knockout. Now remember, knockouts can't be removed from the inside of the box. I need to take something like a large screwdriver. I'm going to put it up in that opening onto one of those knockouts, and I'm going to use my lineman pliers to tap the bottom of the screwdriver. Now, I can't film in there. It's just too darn dark and too darn tight. But I can see where the knockout is. I'm going to take my screwdriver and I'm just going to tap it. Now, a few taps like that is about all it's going to take. I just need that knockout moved up just enough so I can reach in there either with a screwdriver and pry it a little bit more, or with my lineman pliers where I can grab hold of it and give it a good twist. We'll go around the other side and take a look at what we've got. There's a good angle. You can see that I've managed to tap that knockout up from the underneath. So now I'll just reach in there with my lineman pliers and I'll wiggle that guy loose. Okay, so there is the knockout removed, and now we're going to be ready to start threading some wire and using a Romex connector to fasten it in place. Now with the main power off, we're going to put the circuit breaker in right here, right under this breaker. Now I've zoomed in the best I can. It's going to be hard to show this on camera, but basically there's a black clip right here that the breaker fits on. You just put that in place, and then you just push the breaker onto the metal contact. Okay, that should do it. Moved in a little closer where you can see it a little bit better. The breaker's right here. It's the 15 amp breaker. It's currently in the off position. It's in position, locked in place. Nothing's wired up to it, of course, but it's ready to go. All right, so the next step in this process is to cut the hole for the drywall box. I'm going to move the Bluetti stuff out of the way and cut a hole approximately level with the outlet I have over here. So I'll just take a level, take a line across from there, and cut the hole. Then we'll dry fit the box to make sure it's ready to go, and we'll be on to the next step. Using my box as a template, I've outlined a position where I'm going to cut my hole. Now I'm going to use my keyhole saw to do that. Using the saw, I'm just going to punch through this area here. It's pretty thin, so I should be able to get through it. And then just work the saw back and forth, holding the plywood in place. Now I'm using really short strokes because there are some wires in the wall. I could see them up here, and I know, of course, there's other things there. But I'm just going to finish this out, and then we'll come back. Okay, so as you can see, I've got the hole cut out. And now we can put the drywall box in there. All right, well, there's the drywall box. I had a few more tweaks to make the hole just slightly larger than the initial cut, but it's now dry fitted in position. Now, I didn't push it all the way in because I need to run the wire first. So I'm going to take that out, and then we'll go work on getting the wiring run to this location. The next step is to install the Romex connector. First thing we're going to do is remove this lock nut. Then we're going to, with that knockout we've already taken out of the box, we're going to push this up so the threads are inside the box. So this has to be pushed up from the bottom. Then the lock nut is put back on, and that locks the connector into the box. Now once the connector is locked into the box, we can push our Romex wire through, coming up from the bottom, and then using these screws to lock that wire in place so it doesn't move. Now we have a little bit of an issue here, so let's take a look at that before we get started on this. So as you can see, we have a little bit of a problem. Getting that connector underneath the panel from this side is pretty darn tight. From the other side, we've got a small hole to work through, so that's not going to be too easy either. So let's try a different technique. So what I have here is my fish tape, and what I'm going to do is thread on the lock nut, and I'm going to slide that all the way down the tape. Now I'm going to take this fish tape and I'm going to push it through the hole, the knockout, in the box. As you can see, I've got the fish tape going through the hole, and the rest of the fish tape is sitting down here on the ground. The lock washer is right there on the black handle. You can just barely see it. Let me go down there where we can see that a little bit better. So there's the lock washer. Okay, fish tape through the hole. Let's go to the other side and take a look at what we got. You can see the fish tape right there in the big hole. And there it is coming out of the wall. Okay, so we're ready for the next step. Before I pull the wire through, I'm going to pre-install the Romex connector to about that point on the wire. Then I'm going to tape this end of the wire to the fish tape, and I'm going to pull the wire and the fish tape through. That will bring the Romex connector up into the hole, and then I'll be able to put the lock nut on because it's already threaded on the fish tape. I'm going to pre-tighten the screws down, the clamp screws, so that this doesn't move, and I'm going to use a number 2 Phillips head screwdriver to do this. Now these do not have to be super tight, just tight enough so the wire doesn't move. You know, make them snug, Don't make them too tight. We don't want to pierce the jacket and possibly cause a short circuit. Now what I'm doing is taping the Romex to the fish tape. I shouldn't have to do a lot of taping here, just a couple of places, just to make sure it doesn't pull loose. So I'm going to tape it up there at the top, and then I'm going to take another piece of tape and do the back end. So I just use my diagonals to cut that tape to length. And then tape this end up. Now we're not pulling it through conduit or anything like that, so I can probably get by with just a little bit of tape. Otherwise I'd tape a lot more on it. Now once I get this through, the Romex connector should go into the hole and we'll be ready to go. I'm going to start pre-feeding this into the hole, and then I'll go around to the other side and pull the fish tape. Okay, there's my wire. As you can see, I was able to pull the fish tape up, and then I got enough of it up where the wire was visible, and then I grabbed the wire and pulled it the rest of the way. So now I just got to continue to pull the wire until the Romex connector makes contact with that hole. Okay, so there you have it. I've got the wire through, I've got the lock nut on, and I just need to tighten it down. Now I tighten it down by taking a screwdriver, engaging it on one of those lugs, and just tapping it with my lineman pliers, the back of the screwdriver. Once that's good and tight, I'll reroute this wire and we'll be ready to start doing our final wiring. Okay, so I've got the wire in the box now. And what I'm going to do is just knock out one of these openings in the box so that I can run my wire for my outlet. Basically a tap and then bend it in sufficiently so I've got room to get a wire in there. All right, we're going to go in the other room now. We're going to wire up the outlet. Okay, we're ready to wire up the outlet. So we're going to take this box and we're going to slide the wire into that opening. And then make sure the ears are down and the screws are pushed all the way in. There we go. And then we're just going to push it in. And there we go. The box is in. Now we're going to take a Phillips head screwdriver and we're going to tighten those screws down, which will make the box, which will flip those ears up, and then the box will stay in the wall. All right, so we use a Phillips head screwdriver and we just tighten that guy down. All right, just a couple more turns and they're nice and tight. Wiring, which you can do right here. We're not using 14, we're using 12. So we won't be using these back wiring receptacles. Now, let's talk for a minute about the gauge of wire and why we're doing what we're doing. So we started with a 15 amp breaker from Siemens, which is designed to fit a Gould box. Remember, Gould is no longer in business. We now have a matching 15 amp wall outlet. You can buy 20 amp outlets. We decided to go with 15 because all the Bluetti needs is a 15 amp outlet. It's all by itself on that outlet. It's not going to exceed 15 amps. The breaker is good. The outlet is good. That brings us to the last piece of the puzzle, which is the wire. The wire needs to be sized appropriately. For 15 amps, you can use 14 gauge wire. However, I've decided to go with 12 gauge wire. Okay, I decided to do that because if for some reason we wanted to up the amperage, we could change the breaker to 20. We could change the outlet to 20. The wire would be okay. That's the reason. You could have gone with 14. I decided to go with 20. Let's get this job started. To get started on this, we need to rip the Romex outer jacket. We're going to do that using a Romex ripper. Now remember, this ripper has a knife edge in it, which you can see right there. And it closes down on the wire. Okay, probably better to see it that way. So we're simply going to slide it over the wire, okay, and then rip it. Now I'm going to straighten the wire out a little bit and untwist it. Makes it a little bit easier to rip. Okay, so we've got the wire straight, and now we're going to slide the ripper on. And if you need to twist it, you know, if it's heavier gauge wire, you might want to use your lineman pliers to straighten it out. 12 gauge isn't too bad. I'm going to put it so that the tooth is down, okay? And I'm just going to slide that through the opening of the ripper with the tooth down. Now I'm not going to rip too much because this is just a demonstration. Obviously, in working in the outlet, you might want to rip it a little further down. But for demonstration purposes, this is good enough. I'm going to turn it over here, push this down with my hand, and pull. Now, the ripper put a nice, hopefully, groove in there. Looks like it didn't quite go all the way through, so let's do it one more time. Oh, there we go. I had it the other way. And then I'm just simply going to pull that thing back like that. Now this paper is removed. That covers your ground wire. And of course, the inner insulators were not damaged. I'm going to use my diagonals to trim off any excess insulation. Now again, we can make these a lot longer if we needed to for wiring the outlet. Now that the outer jacket is removed, we need to remove the insulation from our hot wire and from our neutral wire. Remember, this device has markings on it to tell you which hole to use for the proper gauge. We put in the proper slot, which is the 12. And again, we don't need a lot, but we need enough that we could wrap this around the terminals. And we could always make it shorter, of course. And then we strip the white wire. All right, now we're ready to proceed to the next step. The first thing we're going to wire up is the ground wire. Remember, the ground wire goes on the green terminal right here. Now, we could do that a number of ways. Let me turn this wire around. We can insert it under the bottom like that and then twist it up around. Or we could go ahead and make a small S-curve or shepherd's hook with our lineman pliers to make it a little bit easier. So I'm going to take the lineman pliers and make a little bend in the wire. Then I'm going to put this in here like so and bend it around the rest of the way. Oop. Didn't want that to come off. Let's get that back on there. There we go. All right. So now I've got it on there, and we simply take our screwdriver and tighten it down. Next, we're going to wire up the black wire. Remember, the black wire goes to the brass terminals. We'll set it on there. We'll take this wire and we'll bend it around. Now, again, ideally, we get that all the way around. Notice how that second screw is kind of in the way. So I'm going to turn that in all the way. And that'll get it out of the way, make it easier for me to bend it. Doesn't have to be real tight, but just get it out of the way. And then if I could grab this guy and bend it down. There we go. And now that's on real tight, real good. Let's just go ahead and tighten that down. And our black wire is now connected. Going to repeat the same process on the white side with the neutral wire or the silver terminals. Going to go ahead and tighten down one of these. Now it really doesn't matter which terminal you use, since these are connected together. I could wire it on the same side, at the same level, or I could use the other side. It really doesn't matter. Okay, because they're connected together by this little piece of metal right here. So this is, either side of this is going to be fine. I'm going to bend this around with the lineman's pliers. Grab hold of that guy. Push it down nice and tight. Tighten down that screw. And that one was a little bit longer, the bare wire. So I'm going to take my diagonals, and notice how it's deep here, but shallow here. I'm going to use the shallow side and cut it as close as I can to that. And that should be fine. So there you go. We've wired our outlet up. Now we're ready to push it back into the box, tighten down these screws here and here, and we're good to go. Again, it was a lot easier to show it on the bench. Now I want to point out, notice how I wired the bottom one here and the top one here. They're not on the same. It's fine, okay, because these two are connected together, and it doesn't really matter. I mean, if you wanted to do both tops, that's fine. If you wanted to do both bottoms, that's fine. If you want to do it this way, that's fine. I don't think there's any reason to do it one way or the other. The only time it would make a difference if this little connector here was broken off, or say the top outlet was controlled by a wall outlet and the bottom outlet was always on. Okay, in which case you'd have to have them wired, exactly across from each other. But in this situation, it's perfectly fine to wire them that way. Now, the last thing we need to do is put the white wire and the black wire on. Remember, the black wire goes to the brass terminals. The white wire goes to the silver terminals. We're going to want to have the ground up. So this side is for your hot wire. You could also remember it's the smaller of the two slots. We only need a little bit of wire. We don't need nearly what we have in here. So we'll cut it approximately here with a pair of diagonals. So we got a little room in case we need to pull that outlet out for some reason. I'm going to use my stripping tool to strip it. Just put it in the appropriate socket and pull. And, oops, must have it in the wrong one. There we go. Okay. And then we're going to do the same with the white wire. Now, nothing's connected, so we don't have to worry about touching these wires. You know, we got the current off, power off. Again, I use my diagonals, cut it to the same length, use my stripping tool, put that on there, and strip it off. Now, right, so the white wire is going to go to the silver terminals, and the black wire is going to the brass terminals. We can't back wire this guy because this is 12 gauge wire, and the most it'll take is 14. So I'm going to lay that alongside the white terminal. Hopefully you can see this. And then I'm going to take my lineman's pliers and twist this around and make a shepherd's hook, they call it. And then I'm going to bend that down and then pull that tight. And then any excess wire I'm going to trim off. All right, that one is connected. Now, straight blade screwdriver, and I'm going to tighten it down. All right, I've got both the black and the white wires connected. I've got them tightened down. We're just going to push this guy back in, align these screws. I'm going to use my Phillips head screwdriver, and I'm going to tighten the down a little bit. Screws that hold the outlet in place. And when we're done with this, we've got one step left as far as wiring goes, and that's to wire it up to the circuit breaker. All right, I'm not going to go all the way in right now, just put it in part way, but that socket, that outlet is ready to go. All right, so we've got one step left, and that's to hook this wire up to the circuit breaker right there, okay, at the bottom. We're going to use the Romex ripper to rip it. We're going to attach the black wire to the circuit breaker. The white wire will go to the neutral bar, which you can see a white wire back there in the background, and that silver bar, that's a neutral bar. And the bare wire will go to the ground bar up here at the top. All right, we're going to start with the Romex ripper. Put it on there and pull. There we go. And that comes out pretty easily. Use my diagonals to trim off any excess. I'm going to strip off the white wire, the black wire. Of course, the ground's okay. Okay, the wiring is complete. Now, the black wire went to this circuit breaker right here, which is currently in the off position. The white wire goes to the neutral bar. You can see a white wire there in the background. That's the neutral bar. There's a neutral bar over here. That's the big neutral from the outside. And then right below it is the other side of the neutral bar. So you can connect it to either side. And then the bare wire, or sometimes it'll be a covered green wire like you see back there, that's going to the ground bar. Now in some boxes, ground and neutral are the same, and other boxes are not. If you want to know why it's like that, please check out the videos on YouTube. There are plenty of people that explain why it's like that. In this box, they are separate. Neutral and ground are separate. Doesn't really matter. Bottom line is, You just follow whatever's in your box. If you have white and green or white and bare wires on the same bar, that's fine. If you have white and bare wires or green wires on separate bars, keep them separated. All right, so that's it. We're wired up. Last step is to put on the cover, turn on the circuit breaker, check that the outlet was wired up correctly, and this project is finished. With all the wiring complete, I've put the panel back on. The breaker is right here on the lower left, and it's currently in the off position. I'm going to turn that breaker on, and I'm going to use my outlet tester to check our outlet. Alrighty, as you can see, I've got the tester in place. I've got 2 lights on indicating that it's wired correctly. The cover's back on. The circuit breaker is on. All I got to do is tighten down this outlet, put a cover plate on, and we're done. The outlet cover is in place. Everything's wired up. Fuse box is covered up, and we are done.